Hello everyone, welcome to my YouTube channel School of Chemistry. Today we are going to study about stereoisomerism. So what are stereoisomers? Isomers having same structural formula. Isomers having same structural formula but different arrangement of atoms of atoms in space are known as stereoisomers. And this phenomenon is known as stereoisomerism. Okay, now let us talk about their types. So stereoisomerism is of two types. Majorly we can say first one is a conformational isomerism. So it arises due to different arrangement of atoms so atoms or groups in space in a molecule, which can be interconverted which can be interconverted into each other by rotation along a sigma bond. For example, we can take the conformations of ethane. That we can draw like this, that we have the ethane molecule, hydrogen, hydrogen, hydrogen. This is the other carbon atom. So hydrogen, hydrogen, hydrogen. This is the eclipse form. And the second structure we can draw like this. This is staggered form. So these are the conformations of ethane. Okay, second stereoisomerism or second type of stereoisomerism is configurational. Isomerism. This type of isomerism arises by arrangement of different groups or atoms in a molecule which can be interconverted into each other by breaking and forming few bonds. Example, this is of further two types. It is of two types, that is geometrical. First one is isomerism and second is the optical isomerism. Geometrical isomerism and optical isomerism. Now what happens in geometrical isomerism? In geometrical isomerism, we can, let us first talk about this geometrical isomerism. So let me first explain you with the help of an example. Let us take a molecule but2e, CH3, CH double bond, CH, CH3. This is but2e. We can draw the structure of but2ene in around a multiple bond like this. That is, we can place the bulkier groups first on one side and next we can place the bulkier groups on the opposite side of the multiple bond. So when the bulkier groups are present on the same side of the multiple bond, we call that isomer as the cis isomer. So this is cis but2ene. And when the bulkier groups are present on the opposite side of each other, okay, then this type of isomerism is known as trans but2e. One is the cis but2ene and the next one is the trans but2ene. So these are the two isomers. We call them as the geometrical isomers. As we cannot rotate this pi bond, as we all know, pi bond are formed by single sigma bond and a double pi bond, and in the pi bond overlapping takes place above and below the plane. So we cannot rotate or twist the molecule, because if we twist the molecule the bond is going to break. Okay, so that's why the positions of these groups which are present on one side and the opposite side get fixed. So such type of isomers we call them as the geometrical isomers. And next is the optical isomers or optical isomerism. So in order to study about optical isomerism, we must first know about the compounds, that which all compounds are optically active. And for that, we must know about the optical activity, that what is optical activity and what all are the compounds which show the optical activity. For that, we need to first know about the polarimeter. So this is the normal light. Now what will happen when we pass the normal light through a Nicol prism? When we pass it through Nicol prism, we will get light only in one plane. We call it as monochromatic light or we can call it as a plane polarized light. Polarized light or monochromatic light. When we pass this plane polarized light or monochromatic light through a solution which contains an optically active compound, so this solution contains optically active compound. What does it do to the monochromatic light? Either it bends the plane of the monochromatic light towards the right, or it can bend the plane of the monochromatic light towards the left. If it bends the plane of the monochromatic light towards the right, we call it as dextrorotatory. Okay, dextro means towards right, and if it rotates the plane of this monochromatic light or plane polarized light towards left, we call it as linear rotatory. Linear rotatory. Linear means towards left. Okay. So what all compounds will be optically active? So for a molecule to be optically active, it must have at least a chiral carbon in it. Now what is a chiral carbon? Chiral carbon. So a carbon atom which is connected to four different groups or atoms is known as a chiral carbon. Let us take an example. If we take an example of this compound, that CH3 C2H5, we can have hydrogen and we can put a bromine, 2-bromobutane. Okay, so this 2-bromobutane will be an optically active compound because it contains one chiral carbon. So this carbon is a chiral carbon. Now what is the property of this chiral carbon? The property of this chiral carbon is, if we draw a mirror image of this molecule, then the mirror image of this molecule won't be superimposable on it. So this one hydrogen, this will be C2H5. If we pick up one of the molecule and try to place it on the other one, okay, then it won't get completely fixed. Like that of alphabet A, if we take the mirror image of alphabet A, it's going to fix completely, but alphabet B, it's not going to fix. Okay, it means alphabet A is symmetrical, okay, or that superimpose on its mirror image, whereas alphabet B doesn't superimpose on its mirror image. So that such compounds which do not superimpose on its mirror image are known as enantiomers. We call them as enantiomers, means non-superimposable mirror images of each other. We have one more term in the optical isomerism, that is distereomers. Now what is this distereomers? So these are non-superimposable non-mirror images of each other. Okay, let me explain you it with the help of an example. Let us take an example like this. We have CH3, CCl, H, and we have CCl, H, and we can have C2H5. Let us take the mirror image of this compound. If we take the mirror image of this compound, this will become like this: CH3, C, we can have Cl over here, hydrogen over here, C, Cl over here, hydrogen over here, and then C2H5. We can draw one more isomer for this compound, that is CH3, C, Cl, H, C, H, Cl, and then C2H5. So this compound is having two chiral carbon. All of them are having two chiral carbon, and its mirror image that can be drawn as CH3, C, Cl, H, then we have C, H, Cl, and then C2H5. Let us categorize them as compound 1, 2, 3, and 4. Now out of them, compound 1 and compound 2 are enantiomer. Compound 3 and compound 4 are also enantiomers. Now what is the relation between compound 1 and compound 3? They are non-superimposable and non-mirror image. Compound 1 and compound 4, again non-superimposable, non-mirror image, but having same molecular formula, same structure. Compound 2 and compound 3, again non-superimposable, non-mirror image. Compound 2 and compound 4, non-superimposable and non-mirror image. It means we are having 4 sets of diastereomers over here. So these are, you can say, the stereoisomerism in carbon compounds. Okay, hope my videos are helping you in your studies. So if you have any query in any of the topic, you can suggest me in the comment section. Okay, and I will surely try to help you out. Thank you.